So today in this lesson, we're going to learn how the unit circle is created so that it's easier to memorize and understand all of the values that we need to know on the unit circle. First, use one color to trace what is the 30-degree angle and then turn it into a right triangle. What we're trying to find is the coordinate for this point on the unit circle, which is created by the arc right here, pi over 6, as well as the 30-degree angle here. Because that's a 30-degree angle, and we made this into a right triangle, we know that this is a 60-degree angle. Because it's a 30, 60, 90 triangle, we can use the ratios from our 30, 60, 90 special right triangle information. What we do know about the unit circle is, what we mean by unit circle is that the radius is 1. So we know here that the hypotenuse is 1 because it's on the unit circle. If the hypotenuse is 1, then we know that x is going to be 1/2 because we would solve this equation. And if x is 1/2, then this is going to be 1/2 times the square root of 3, which is square root of 3 over 2. Meaning that the base of the triangle is square root of 3 over 2, while the height of the triangle is 1/2. So to get to this coordinate, we would go to the right from 0 to the right, square root of 3 over 2, and up 1/2. And that's the coordinate for the 30-degree angle on the unit circle, or the pi over 6 angle in radians. Next, we're going to talk about the 45-degree angle. So in a different color, let's trace the 45-degree angle and make a right triangle out of that by making a line go straight down from that point. And we also know here that if this is a 45, 90 triangle, the radius is still 1. And then if we solve for x, square root of 2, x square root of 2 equals 1, we'll divide by square root of 2 on both sides and get x equals 1 over square root of 2, which we don't want to leave like that. We'll multiply by square root of 2 over square root of 2, which gives us square root of 2 over 2. So both the base and the height are square root of 2 over 2, which leads us to believe that this point right here is the coordinate square root of 2 over 2, comma, square root of 2 over 2. And that'll be every 45-degree angle on the unit circle. Now we'll talk about our 60-degree angle. The last angle, trace as a 60-degree angle, and turn that into a right triangle. And we know that the bottom angle is 60 degrees, which makes the top 30 degrees. And we're still looking at a 30, 60, 90 triangle like we were in the 30-degree angle, except for that it's facing up. So it's going to be a little bit different. We still know that the hypotenuse is 1. And if the hypotenuse is 1 on a 30, 60, 90 triangle, then x is going to be 1/2. And again, if x is 1/2, then the long leg is going to be square root of 3 over 2. So now to find the coordinate, we're going to go to the right 1/2 and up square root of 3 over 2. Okay, so the goal here was to find the coordinates of the 3 angles in the first quadrant of the unit circle. Now we're going to use other tricks in the unit circle to be able to find all the pieces that we would need to normally memorize, but instead we're going to have tricks to find all of them. What we mean by counting by radians is that there's tricks on the ways to find the radians. What we know from learning our conversions is that 360 degrees is 2 pi. Half of that at 180 would be pi. Half of that is pi over 2. And if every 90-degree segment is 1 pi over 2, then this brings us to this bottom angle being 3 pi over 2. Okay, so those are what we call quadrantal angles. Now we also have our 30-degree angle, which if you converted would be pi over 6. Our 45-degree angle, which would be pi over 4. And your 60-degree angle, which is pi over 3. And the trick to find the angles in radians in the other quadrants is that quadrant 2 is what we call the subtract 1 quadrant, where every denominator, the number in the numerator is 1 less than the denominator. So this is 5 pi over 6 because it's the pi over 6 angle. The middle one is 3 pi over 4 because it's the pi over 4 angle. So the denominator is always 1 more than the numerator, meaning we subtract 1 from every denominator. This is the plus 1 quadrant, where the pi over 3 angle in this quadrant, we're going to add 1 to 3, so it's 4 pi over 3. And this is the times 2 minus 1 quadrant. So if I wanted to find 5 pi or pi over 4, we would times 4 by 2 and get 8 minus 1, which is 7 pi over 4. So what's important here is labeling them as the minus 1 quadrant, the plus 1 quadrant, and the times 2 minus 1 quadrant. Another trick that we use is that all the coordinates that we found over here in the beginning, they're all the same throughout the unit circle, except for the signs are going to be negative, positive in quadrant 2, negative, negative in quadrant 3, and positive, negative in quadrant 4. This is what we call the reference angle quadrant, and those signs are positive and positive. Now we're going to draw which angles correspond with each other. So I would use a different color for this if you have it. We know that the 30-degree angle is going to go with every 30-degree angle. So all of the angles that are 30 degrees away from the x-axis, all of those will have the same coordinate. That coordinate is square root of 3 over 2, comma 1/2. It'll be exactly the same over here, but it'll be negative square root of 3 over 2, comma 1/2. And here, negative, negative square root of 3 over 2, 1/2. And here, positive, negative. Okay, and then next, so these are our 30-degree angles. Now we also have our 45-degree angles, which are all the middle angles. That's not good. Okay, so all of those will have the same coordinates, which we know are square root of 2 over 2, comma square root of 2 over 2. The last one is our 60-degree angle, which is the highest angle in the first quadrant, and all of those are all 30 degrees away from the y-axis, or 60 degrees away from the x-axis. Those are all of our 60-degree angles that have a coordinate of 1/2 square root of 3 over 2. Okay, and the last thing that I like everybody to know is that all of the little slivers on the unit circle are 15 degrees, and all of the larger slivers or angles or arcs, sectors on the unit circle are 30 degrees. That way, when we're about to count around the unit circle, you know how much to count by. So now we're going to use everything that we learned in this video to create a full unit circle. So number 1, we know that this starts at 0. So let's start with all of our degrees. From 0 degrees, we're going to go up 30, which creates a 30-degree angle. By 15, that would create a 45-degree angle. Up 15 more, 60-degree angle. Up 30, 90-degree angle. So again, the bigger sectors are 30 degrees and the smaller ones are 15. So 90 plus 30, 120, plus 15, 135, plus 15, 150, plus 30, that's our 180-degree angle, which makes sense because it makes a line. Plus 30 is 210, plus 15, 225, plus 15, 240, plus 30, 270, plus 30, 300, plus 15, 315, plus 15, 330, and plus 30 brings us to 360 degrees. So that's how we would count if you had to create this on your own, which is the goal, is to count all of them by 15s and 30s, so you get all the way around the circle. The next thing that we're going to do is label the radians. We know that this would be 2 pi radians. Half of that would make 180 pi radians. Half of that is pi over 2. And 3 segments of pi over 2 brings us to 3 pi over 2. Those are what we call the quadrantal angles. Now, from our conversions, we know that 30 degrees is pi over 6, 45 is pi over 4, and 60 is pi over 3. So you can convert those every time, or you can memorize them. Notice that they go 2, 3, 4, 6, it skips 5, or whatever you need to do. But we have to know the first quadrant so that we can go find the other ones using the trick. Remember that the trick is that this quadrant is the -1 quadrant. So the pi over 6 angle, which is right here, goes with this angle. So if that's the -1 quadrant, then we're going to take pi over 6. 6 minus 1 is 5. Therefore, this is 5 pi over 6. The pi over 4 angle, or 45 degrees, goes with 35 degrees. So if that's pi over 4, now this is going to be 3 pi over 4. The 120-degree angle goes together with the 60-degree angle. And if that's pi over 3, then this is going to be 2 pi over 3. Okay, all of the same things apply here. I'm going to run through this quickly. And these go together. All the ones that end in 5 or the middle angle, they all go together. And all of these go together. So in the 210-degree angle, which is 30 degrees, this is the +1 quadrant. So 7 pi over 6, 5 pi over 4, 4 pi over 3, and same thing, 300. Now it's a times 2 minus 1 quadrant. So we're taking pi over 3, and times 2 is 6, minus 1 is 5 pi over 3. 45 degrees, 4 times 2 is 8, minus 1 is 7 pi over 4. Pi over 6, 6 times 2 is 12, minus 1 is 11 pi over 6. Okay? The last thing that we talked about was the coordinates. Square root of 3 over 2, 1/2. Square root of 2 over 2, square root of 2 over 2. And 1/2 square root of 3 over 2. We know that they all match with their other angles, but with different signs. The easiest way to memorize this is that you have 3, 2, 1, 3, 2, 1. Every numerator has a square root, except for 1, because the square root of 1 is 1. And every denominator is 2. And then all of the same apply as long as you know which angles match with which angles.